Today in this workshop, I would like to dive in. It's going to be separate into two parts. In the first part, I would like to present a quick overview over how to use MicroDraw for open collaborative projects and present a short overview of collaborative projects around the world that have actually used MicroDraw and also BrainBox, our tools for working collaboratively open with histology as well as with MRI data. And histological data is unique in terms that it provides information about the fine structure of the brain and has been collected for more than a century for an incredible number of species. And that makes it super interesting, but also challenging to work with. And here's one of the beautiful collections, the Comparative Mammalian Brain Collection, where we have more than 44 specimens that we indexed in MicroDraw. And we have a beautiful collaborative project with many different people involved to segment the cerebellum of these species and dive into allometric analyses. And what's difficult with histological data is that there are certain aspects very challenging about it, like data can grow very big, and so that it becomes difficult to share with other people and to work together. And also it requires a huge anatomical expertise. So often manual segmentation is then performed by a trained expert human, which makes it also difficult to work together. And the mission of MicroDraw was that we have this collaborative website where everybody can connect to the same data set, zoom in endlessly until the cell level, can set up projects and accumulate different histological data sets into thematic projects and work together with people across distributed research labs in the segmentation of these data and the analysis of these data. And we have a sister project called BrainBox, where we do the same efforts for MRI data. And here's just an example for the ferret brain development project from Roberto Toro's lab. We also have, this is a beautiful project from Alexandra de Sousa's team in the UK. They have digitized the Stefan collection together with Carol McLeod and analyzed the cerebellum of great ape species and primates. And here's one of the projects we started together to analyze the cerebellum of a gorilla. And we used MicroDraw to, together with the team of Alexandra, to delineate the cerebellum across the primates and great apes. And afterwards, we have even been able to, these are the segmentations we have done so far. So we do the cerebrum and the cerebellum. And we were even able to use, download the data and perform a first rough reconstruction of the 3D surface of the cerebellum of a gorilla in this case. And from there, we can continue to go higher resolution and more detailed surface reconstructions. That's work in progress. This is the project I quickly mentioned earlier, where we're looking across many, many different mammalian species from the Brain Museum collection, together with colleagues around the world to segment the details of the cerebellum and perform an allometrical analysis. And this is a project led by Sophie Falk with her research group at the Max Planck Institute in Leipzig in Germany. And she started an endeavor together with Neville, her PhD student, to segment the cerebellum of more than 34 different primate species. And here's a cerebellum of a Hamadryas baboon, for example. And they are now doing surface reconstructions for these cerebelli and measuring the volume and the evolution of the cerebellar volume. And it all happens distributedly from home and different countries and using BrainBox. And another project that happened on BrainBox to collaborate on the analysis of open data is, for example, to analyze the cortical thickness across all these different primate species, more than 34 different species, a project led by Maria Holland and her team. And now back to histological data. I would like to show one example in analysis of the giant anteater for what we can do and until through the analysis of cortical gray levels and surface reconstruction. And then we can dive into Google Collaboratory together, where we can look at the code, how we use MicroDraw to query the data and analyze the segmentations, put them together to analyze volume and surface area, for example. So we got the giant anteater data from the brainmuseum.org website, and we were able to index this data in MicroDraw. So we were able to delineate the cortical outline. And then from there, we were able to use optimal transport algorithms to find the white matter interface. And we were able to align the cortical slices and reconstruct the 3D surface of the giant anteater. And we performed an analysis of the gray levels that we extracted across the slices. And here you can see the pattern projected onto the surface of the values that we extracted. And that's just one example. There are many different species for which we have done that. And all together with a team of distributed people working together with MicroDraw. And now I would like to stop presentation, but go into a Google Collaboratory. I hope you can, my computer struggles. Okay, now you should see my notebook, right? So here is it's an example from the Brain Museum again, a squirrel monkey. And for this data set, we have created a project on MicroDraw. And you have seen who has been at the last Heuer workshop has been segmenting this together with us. So we were all connecting together and everybody of the participants did one slice. And so at the end of the workshop, we had all the slices of the squirrel monkey segmented. And now we can leverage that to analyze them together with MicroDraw. We created a Python package that can be used for the downloading and the analysis of the slices that comes together with a MicroDraw web interface. It's called microdraw.py. And so we can clone the project and install it. We can then import it as a library. So we will use NumPy and we will use matplotlib and we will use the MicroDraw package. And all we have to do then is setting project details. So on MicroDraw, it's very easy to go and create a project. And I will show you for example, here is the squirrel monkey project. And I can add people that I'm collaborating with directly as collaborators, and I can give them different access rights. So I could choose to make them only see things, or I can give them edit rights, or the right to add collaborators or remove collaborators. And the same for annotations, and the same for the data files, the histological data files. And then I can define an annotation layer where here it's the serial that we were interested in, and it's a vectorial layer. You can also add text annotation. So if you want to add a comments field, for example. And in this way, you can set up your project to the needs that sorry about that, that requires your project. So it can be completely open or open to collaborators only, or invisible just for yourself. And all you need is then to point MicroDraw to a JSON file that points to your data. The data is hosted in DZI format, and there's various ways. We use the VIPS library to convert histological data to deep zoom format, and that needs to be hosted on any server, and that can be your Google Drive, that can be GitHub or Zenodo or wherever you like. It's big files. So there is the European platform that's being built now. And also Zenodo work very nicely for these endeavors. And then you can go to the project. Save your settings and go to the project. So you have an index here, and that's how you set up your data. And then we go back to the analyses. Squirrel monkey. And we define these project details. So the project, we call it Squirrel Monkey. And the source URL is the MicroDraw URL, where we point to the JSON that holds the URL to all the DZI images. If you make a private project, you will need to have a token. Here we can leave it open because it's a public project, but if you want a token, you have to be logged in, and then you just go to microdraw.pastor.fr/token, token, and you will receive your token. It's valid for 24 hours. Okay, here we leave this empty, and then we can download and display annotations. So first, we can do that for a single slice to test that everything works all right. And so we define which slice we want to download. In this case here, it's slice number 0. And then we define to get the regions from this slice. So everything that has been annotated in this slice, we will get it here. And then we can color it with different colors. So we see here the 2 cerebral hemisphere. And then we can download for the entire data set. So all the slices. That takes a little while, like 2 minutes or something in my case. And then we can draw this entire data set, just like this, also using the MicroDraw.py package. And here we can see that actually we don't only have the cerebral hemispheres, but at some point the team of Sophie has started to annotate the cerebellum. And for the analysis of the cerebral volume, we would like to exclude this. So in the next step, we can define which parts we want to keep for analyses. So here I have, for example, singled out one of the slices, number 42, that has the cerebellum annotated as well. And so we know we can go to MicroDraw. These colors, region names, we will need them. They actually correspond to these colors. And when you click here, you see the names. So this is region 1, region 2. In the end, we will plug an ontology here. For the moment, it's just colors. And so for the cerebral hemispheres, we chose red and orange. And this is what we're going to use for the analyses. And the cerebellum was region 8. So if we were interested in analyzing the cerebellum, that's the region we would want to include here. And this is what we do here. So we take all the regions and then we look for region 1 and 2 to get only the cerebral hemispheres without the cerebellum. And oops, sorry. Once we downloaded that, we can compute the PL surface area and the brain volume, for example. And here in this case, it's coming from the Brain Museum. So we had to measure what's the size and the resolution, how many pixels we have in the image. So what does correspond to this 1 centimeter that we see here in the image, so that we get actual mapping from MicroDraw to the data. But these are parameters that you usually get in your, when you scan the data, you have all this available. And so to get from MicroDraw to the histological units, that's just like the little conversion where we go, here we need to get that from an image, what's the actual size of the brain. We got that from here, the expansion, anterior, posterior, so that we could perform our analyses for the squirrel monkey. And so we get our scaling factor and the interslice space. And then we can compute for the first slice, for example, here slice 51, the perimeter, this outline, and the volume of the cerebral hemispheres in this one slice. That's what we do here. So we define that we want to get the region volume, the perimeter, and the surface area, again for region 1 and 2. And here we compute it using our mapping between MicroDraw and the histological data. And then we get our results. Yay! And then we can do that once it works for one slice. We can do that for the entire data set. That's what we do here, where we add up we do it like for the single slice as we did before, and add them all up for the entire brain. And given the interslice spaces, we can compute the volume of the cerebrum. So in conclusion, that's what we do with MicroDraw and MicroDraw.py, completely collaboratively with many people in distributed labs. And we're happy about everybody that would like to join our mission. We had beautiful hackathons together with people from Jülich, including Chao and Timo's team. And we had collaborations from Montreal around Alan's team. And we're looking forward to working with all of you if you want to help testing or if you want to help us coding and would like to stay in touch with you and improve MicroDraw either way. Thank you very much for your attention. And then on Thursday, we're gonna look at a new feature that will be presented by Roberto, where we will present how we not only can manually segment from scratch, but how we can use a random forest segmentator to get an initial start and iterate between manually refining the result, going back to training and going back to MicroDraw. Thank you very much.
Thanks a lot, Katja. There's plenty of space for questions or even for collaborative work.
Happy to segment the brain together if you're up for it.
So there's nothing in the chat yet. Anybody raising hands? Oh. There's some volunteer to segment.
Sorry, did you say there's a question?
No, there's no question. There's a volunteer for segmentation.
Yes, there is a question as well. So what is the back end for MicroDraw?
It's HTML, JavaScript, and based on the database is based on MongoDB, and we are using Vue.js more and more. It's currently trying to get rid of jQuery.
That's indifferent, but in the backend it's Node.
And Node, yes, Node.js. And we're also integrating more and more testing into MicroDraw. So if you would like to help coding, that's what we have. Like linting is all in place, and now we're integrating unit tests and end-to-end tests using Mocha.
Hartmut is asking about the maximum data size that can be processed with BrainBox.
That depends on the connection. Like we have already had super high resolution MRI scans on BrainBox with no problem. Even the BigBrain is there. The 60 micron, I think, cerebellum we have on BrainBox also, and it works slower, but it does work. The file size of that one was, I would have to check, several hundred megabytes, but in BrainBox, yes. And then so for higher resolution, we then go to MicroDraw. MicroDraw is faster because it splits up the entire image into the pixel tiles, so into the image tiles in the pyramid of tiles, and that's why it's faster. But for MRI data for several hundred megabytes, it does work very well also with BrainBox. We also have an embryo histology data on BrainBox, which is nice because we can do the 3D reconstruction on the fly. There was also a question, would you be able to segment only the white matter? Yes, it just depends on your selection, like what you do in MicroDraw. Am I still screen sharing? No. We can do now a segmentation together if you like. I can share a data set and we all meet there. Share screen. And if I go to MicroDraw, these are the tools that you have available in MicroDraw. So you can draw either a Bezier curve and then modify the points based on the structure you're interested in, or you can draw a polygon line, my preferred tool, and you can choose whichever structure you want to segment and manually go ahead. And also we have a threshold tool. Where you can select based on the threshold and then say, yes, this looks good and I want to add these regions. Here it's now for the gray matter, but you can also just go and take a tool and go segment this line. It's faster if you take a pen and an iPad. Now I'm with my computer and a bit slower. And then you can also, like, depending on which structures you're interested, you can always zoom in and out and refine your segmentation. Does that answer your question? I see lots of people undefined. Here's the login. The login just uses GitHub, and then your username will appear if you want to log in. I will just close the region here. And then you can come back and add another one. You can add them together so you don't have to do everything at once. I added the wrong one now. Sorry, you can undo. This is because one went into the background. This one is actually in the front now. So I can move it to the back and then access these regions and combine them. Look, that's what I would have wanted to do. So this is the tool palette of MicroDraw, and these are the drawing tools. So you can also just draw a line. So if you want to delineate cortical regions, that tool would be of interest. And otherwise you can add points if you're not happy with the detail of your line, you can remove points. You can add regions together, which is what I just did, or you can subtract regions from each other. And then you have the exact cut here. Or you can divide regions based on each other. If you want to find substructures, then you could divide this region from this one and would have the exact border here, which makes it into two regions, which then you can independently from each other move or just analyze them independently of each other. Give them different colors so that you can then distinguish them. You can also flip and rotate them and move them to the other hemisphere. If it's a symmetric structure, for example, that could give you a first good starting point when one structure is segmented in one hemisphere to move it to the other, or even to copy it to the next slice. Copy, and then you can go to the next slice and paste it. I will paste the link to this project on the Zoom as well, and you can feel free to play around. Could you elaborate about how Brainbox or MicroDraw communicate with servers? How can users bring in their own data, unless you are keeping this for the next presentation? Now we can, basically you take your histological data, and MicroDraw needs it in the deep zoom format. So you convert your histological data to DZI format. We use VIBs, for example. It's a free library, and you can call it from like Bash from Python. And convert your data. And then once you have your tile pyramid, you need a JSON file, which I can show how they look like, which points to your data. So it would define what's the resolution of your data, the pixels per meter, and an index of the tiles folders that were produced by the conversion. And that's all you need. And this JSON file and your data needs to be available on a server. So that can be your institute server. That's ideal if they do the hosting. We host our data at MicroDraw at the Pasteur server. We can also host data for you, but it's better that your institute could host that for you.
I think the question concerns not the API. Was it hosting of the data or communication with the applications?
Maybe you can show. It's this question.
Yep, so all the communication goes through an API. Everything basically that you can see in the interface, you can also get just the corresponding JSON file. And you can get, if it's data that's private, then in that case, you will need a token. And then using that token, you will be able to do anything that you would be able to do through the graphic interface. So for example, the tool I will be showing on Thursday, it's a different website that has a Python version of the random forest segmenter, trainable segmenter. And what you do is you have images in MicroDraw. It can work in any other of our tools, but in this case it's MicroDraw, and you give an example of what's the white matter, an example of what's the gray matter, an example of what's the background, etc. Then this external website will, through the API, query that image, query those regions, and then use that information to obtain a set of a bunch of different features to try to distinguish from these three different classes. And then there will be a segmentation of the whole image and eventually many slices based on those examples. And then the result can be sent from this external website back to MicroDraw. So what we would like to illustrate is the possibility of anyone creating instead of creating the whole manual drawing, visualizing thing again from scratch, you can just rely on MicroDraw, use it as your external service for manual drawing, then focus on, for example, your deep learning algorithm, your very clever segmentation method, and obtain the information that people manually segmented for you through the API, and in the same way through the API, send back the results, which can be eventually refined by users, using the graphic interface. And we are at the moment working in making the API like generic, so that the same API that we use for BrainBox will be more or less the same for MicroDraw, with the difference of things which are specific to histology or MRI. And then what we would like to do is to reuse this API for all the different tools that we are creating in the lab, so that the same thing could be used. If you have code for one, you can easily translate it to some other one. And also, like, if someone wants to just communicate with our tools, it will be so much easier.
And also parts of how our API works is visible in the link, like how like the slices can be queried, the project can be queried. The data
just using if you use a simple CURL or any other web query tool, you will be able to get the JSON file that describes the data set. And then it's also possible to get information at a given resolution. However, that's not necessarily the best idea if you have an image that's 25 gigabytes, because it will take just forever. So I think, but it's possible. You just have to be very, very patient. But at some point, it doesn't make sense to use the MicroDraw to be your way of getting the data that you could just get from Zenodo or something. For example, we have data from the Allen Institute, all the macaque data in a pyramid of resolution. We index that through MicroDraw so that we can actually draw on top of it and then collaborate with that on top of that data. But it's really like a lot of data. It's hundreds of gigabytes of data. It's not a clever idea to, and then because this is a pyramid of scales, actually each slice, it's probably 200,000 little tiles. So if you try to download them from MicroDraw, it will take ages. If you try to download the highest resolution. Of course, if you want just an image of the size of your screen, or a few thousand pixels wide and high, that's perfectly fine, and you can get that through our API. Which is actually what the trainable segmenter does. No, it will get a relatively low resolution version of the image to try to get the statistics from the image corresponding to the different classes that you indicated.
Maybe I have a question. Thank you for your nice presentation, Katja. Having also worked with your tool, I wondered, like, do you plan also in the next 3 to 5 years also to implement more automatic or maybe deep learning automatic segmentations that you then added by hand, or would this be like beyond the philosophy of the tool?
No, like, it's amazing. That's like what Roberto will show on Thursday is the first step. It's not that we want MicroDraw to grow massively, but it's more like modular thinking. So it's like an interface where anybody could come and plug yet another module. So the random forest segmenter that he was just integrating can serve as an example where you can come and add more algorithms and other algorithms. And would be nice just to have this forth and back immediately integrated, because we have the experience, like, I think we all made the experience that you get to a certain depth and level of detail with an algorithm, but then you're happy if you can actually go and manually refine it, because our eyes are still the...
Yeah, well, I think that there's always the risk of turning into something like Microsoft Word, you see that has so many functionalities that at the end, when you just want to make your text bigger or smaller or italic, whatever, you are unable to find where to change the spacing. So we would like MicroDraw to be just a very good tool for manual segmentation, and then that you can create your projects and share them with people, etc. But then rely on a way of like outsourcing all the more clever automatic algorithms to people that want to focus only on that. And yeah, so instead of trying to achieve world domination, we just want to have a very, very good tool for manual segmentation.
Yeah, although, anyway, and I also wanted to ask, like in MicroDraw, you already had like that you can correct in one slide and it seeps over to the next one, so that you have like 3D segmentation, or is that already implemented? Because I wondered, it would be useful, like, for example, if you're delineating something that you see in the next slide, what you did in the previous slide, so that you already have a prior, or at least a start of the next slide.
What is there for the moment is just a simple copy of one region to the next slice. We use that especially when data is damaged, when there's tissue parts missing, or when it's very distorted or very pale one part. Then we can use information from the adjacent slices, superpose them, and find the middle way where we expect the unhealthy section to be. And so that works nicely. And a first step in the direction of real like 3D, what you meant, like more across slices in a clever way, would be the reinforced segmenter that learns based on one slice that you annotate, but can then be applied to all the slices of the same brain.
Mm-hmm.
And that works quite nicely. Like the level of detail that you get within one slice often is very the same across the other slices. Then.
Yeah. What's nice is that if you realize that there's some regions where your classes are confused, etc., you can just give another extra example concerning that. You know, tell the algorithm that this region actually is white matter, not gray matter, and then it will retrain the classifier and resegment everything again.
Mm-hmm.
Yep. And even the same with the threshold. Like if you're happy, we have this other tool that we use for segmenting MRI data. And very often, just with a simple threshold, it's called threshold man. And so with threshold man, what you can do is you adjust a threshold, but locally. So you pick a point, and then that will be the threshold that's valid around that point. Then, of course, that threshold will not work in a different region. So you can go to the region where it fails, put a point, and then readjust your threshold there. And the code will make like an interpolation of all your thresholds, like a varying field of thresholds, and you can keep working on that one until you are happy with your segmentation. So something like that could be also used for MicroDraw. But there's so many things that we could do that if we kept adding them all, at the end, half of the screen would be the different tools, and probably like 90% of them, no one will use them. So I think that it's better to have, like, I like better the idea of the microservice, where you have a thing that does one thing and does it very well. And then if someone wants to contribute, it's very easy also to chime in. And that will be the case of the random forest segmenter. And also we have stuff using UNets and more fancy deep learning if there's enough data that sometimes work very nicely. But again, instead of blotting the MicroDraw interface, I think that we will just create another special website for that will be able to communicate with MicroDraw. And in that way, like anyone could also, if they have a nice tool and they would like to use MicroDraw or any of the others, because there's a common API, they can all just communicate together. There's no need for us being the bottleneck.
Mm-hmm. And can you theoretically also have like other files than the brain to segment, to say like including, say, spinal cord or other anatomical images that you want to use, or you can just use whatever file with a certain format?
Yeah. And for example, the massive poster walls that you've seen where people can zoom into their poster among 1,400 other OHBM posters, it was MicroDraw. So we just put all the posters together as if it were one big histological data file, and then split it up into the tile pyramid and used MicroDraw for showing the posters. and then people can click and go to the poster and join. And,
what would be nice, I think, for MicroDraw is if it were possible to, you know, the atlases that we often use, like Macaque Atlas, Mouse Atlas, etc. If there were this tool that would allow you to create something of the quality of a published atlas just from the web browser, and that will be Wikipedia-like, you know, so that anyone can participate, or fork the atlas and then, you know, divide the nuclei in some region in a different way, etc. But like all the tools necessary for going from the website to a PDF that will basically have the whole atlas, knowing that's also like a living atlas. No, you can go and use it for stuff. It's not just for visualizing.
Mm-hmm.
That's what nicely has happened already now with the BrainBox data, where you have the cerebellum segmentation now, thanks to you and your team, and the cortical thickness segmentations, thanks to the team of Maria, and the cerebral and the whole brain segmentations. And so it can grow little by little. Now there's like you want to focus on subcortical structures, so it will grow and grow, and that can be the same in the histological data sets because everybody has access and can go and
there's been already the beginning of a collaboration with Rembrandt Bakker to integrate also MicroDraw within the scalable brain atlas. That's also something that can be very nice because it opens like a bunch of region definitions in ontology and even mapping to neurons in the more recent version of the scalable brain atlas.
Yeah, very cool.
Thank you. Thank you for the questions. It was a nice discussion. There's one more question. Will there be a tutorial video importing an MRI scan to segment? And are you able to get volumetric measurements of the segmented areas? For MRI, we are using BrainBox, and it is like you can host in Nifty GZ format or in MGZ format your data, either on Zenodo, Google Drive, Dropbox, any place where it has a URL that is openly accessible. As soon as BrainBox can see it, you can visualize it with BrainBox and annotate it with BrainBox. And then for analyses, that's something that Neville has, for example, done for the cerebellum. He created a Google Collaboratory notebook where he queries the data, downloads the segmentation, and can compute volumetric measurements on the segmentations. They're also displayed in BrainBox itself. As soon as you segment, you see the volume measurement changing. I hope that answers the question.
And at the moment, all the like fancy data analysis, we do it offline, mostly using Python for surface reconstruction and like measurements of folding or things like that. But I think that through the method illustrated with the trainable segmenter, it should be possible to move eventually all those services to individual websites, you know, like one that would query BrainBox or query MicroDraw to generate a very, very nice surface reconstruction, for example. And then even like we have been working on this tool that's also web-based for editing the mesh, because very often meshes require quite some manual editing afterwards. And at the moment, the tools that we use and the tools that we know people use are all offline. But it would be nice to have also integrate the idea of collaboration for that type of work as well. Or potentially for diffusion weighted imaging data. There's also like viewers that work very nicely for segmenting, for reconstructing streamlines and stuff. So it would be possible to create annotations or place the right regions of interest in a diffusion data set to kind of collaboratively segment some interesting brains.